I hope all of you are doing good. Let's start today's chapter, factors and multiples. Prime number, a number greater than 1 which has no factors other than 1 and the number itself are called prime numbers. You already know about them, right? See, all these numbers are prime numbers. So, 2 is the only even prime number. Otherwise, all of the prime numbers are odd. Number 2, composite number. Whole numbers greater than 1 which are not prime are called composite numbers. Okay. See, all these are composite numbers, or also you can say that numbers which are having more than 2 factors are composite numbers. Okay. And 1 is a unique number since it is neither composite nor prime. It is only a factor of itself. Okay. Next, multiple of a number is a product of that number and a natural number. Example, here are given 5 into 8 into 8 is equals to 8, 8 into 2 is equals to 16, 8 into 3 is equals to 24, 8 into 4 is equals to 32 and 8 into 5 is equals to 40 and so on. A factor is a divisor which divides a number exactly leaving remainder 0, right? For example, factors of 40. So 1, 2, 4, 5, 8, 10, 20 and 40 are the factors of 40. Means all these numbers divide 40 without leaving any remainder, right? A prime factor is a factor which is a prime number. Example, prime factors of 60. So, prime factors of 60, 2 into 30. Now, we will write it as 2 into 2 into 15. Now, 2 into 2, 15, we can write as 3 into 5. So, 2 into 2 into 3 into 5. These are the prime factors of 60. 7 is a prime factor of 35 and 5 is a prime factor of 35 too, right? Next, co-prime numbers. 2 different numbers that do not have a common factor other than 1 are called co-prime numbers. Example, 12 and 17. These have no common factor other than 1, divisibility and divisor. If a number can be divided by another number with 0 remainder, then the second number is the divisor of the first number. Consider the number 18. Its factors of 18 are 2, 3, 6, 9 and 18. So, all these are the divisors of 18. Okay. Now, let's do the revision of divisibility rules which we learned in the previous classes also. Okay. If we have to check the divisibility of 2, what will you do? What is the rule? If one's digit is even or a 0. Okay. Number, if divisibility by 3, if the sum of its digit is divisible by 3. Okay, for example, 27. Let's add this 2 plus 7 is equals to 9. 9 is divisible by 3. That means 27 is also divisible by 3. 4. If the number formed by its last 2 digits is divisible by 4 or last 2 digits are zeros. Okay. Last 2 digits are 8. Last 2 digits are double 0. Okay. 5. This is very simple. To check the divisibility of 5, if its one's digit is either 0 or 5. For example, see these numbers. Unit digit is either 0 or 5. 6. If it is divisible by 2 as well as by 3. Okay. For example, 12. 12 is divisible by 2 because it's an even number, and by 3 also it is divisible by 3 also. So, the number 12 is divisible by 6 also. Okay. 9. If the sum of its digit is divisible by 9. For example, we have a number 36. 3 plus 6 is 9. 9 is divisible by 9, therefore 36 is also divisible by 9. 10. If its one's digit is 0, this is the simplest of all. If one's digit is 0, that means it is divisible by 10. Okay. Number 11, if the difference between the sums of the digit in the odd places and in the even places is either 0 or divisible by 1. Okay. For example, 1, 2, 1. This is first place, odd place, even place, odd place. So, sum of odd place is what? 1 plus 1, that is 2, and at even place there is 2. So, difference between them is 2 minus 2, that is 0. Okay. 12. If it is divisible by both 3 and 4, and 15 if it is divisible by both 3 and 5. Okay. Now, divisibility or by some other numbers. We shall study a few other cases of divisibility involving prime and composite numbers. Divisibility by 7. A number of 2 digits is divisible by 7 if the sum of 3 times the digit at 10th place and the digit in the 1st place is divisible by 7. Number 2, a number of 3 or more digits is divisible by 7 if the sum formed by the last 2 digits and twice the number formed by the remaining digits is divisible by 7. For example, 1225. Here 12 into 2 plus 25 is equals to what? 24 plus 25 is 49. That means it is divisible by 7. Now you can consider another example, which is 13,027. So 130 into 2 plus 27. This is 260 plus 27. 287. This is divisible by 7. That means this number is also divisible by 7. Now divisibility by 10. A number is divisible by 10 if there is a 0 in one's place. Okay, for example, 180 is divisible by 10, 210 is divisible by 10. Divisibility by 18. We know that 18 is equals to 9 into 2. So where 9 and 2 are co-primes. Hence a number is divisible by 18 if it is divisible by both 2 and 9. This we see a number is divisible by 18 if its units digit is even and the sum of its digit is divisible by 9. For example, 72. Okay, 72 is an even number, so it is divisible by 2. 7 plus 2 is what? 9. 9 is divisible by 9, that means 72 is also divisible by 9. That means 72 is divisible by 18 also. Okay, divisibility by 25. A number is divisible by 25 if the number formed by its last 2 digits is divisible by 25 or if the last 2 digits are zeros. For example, 13575. We need to check only last 2 digits. This is divisible by 25. Okay, and 8500, last 2 digits are 0. That means it is also divisible by 25. Right. Next, divisibility by 125. A number is divisible by 125 if the number formed by its last 3 digits is divisible by 125 or if the last 3 digits are zeros. For example, let's check the last 3 digit number, 375. If 375 is divisible by 125, then this whole number will be divisible by 125. Okay, and 1000, there are 3 digits, 3 zeros, so it is divisible by 125 because its last 3 digits are zeros. Okay. Exercise 6.1. Look at the table given below and mention if they are divisible by the numbers given in the left column. Okay. 88 is given here, if it is divisible by 6 or not. So 88, this is divisible by 2. Okay, now let's check whether it is divisible by 3 or not. 16, no, 16 is not divisible by 3, so it is also not divisible by 6, no. Okay, 144 is divisible by 2 and by 3, let's check. 4 plus 4, 8 plus 1, 9. 9 is divisible by 3, right? That means this number is divisible by 3. So this number is divisible by 3 and 2 also, 2 and 3. That means it is also divisible by 6. Okay, students? Highest common factor or greatest common divisor, HCF or GCD. We know that the highest common factor of 2 or more whole numbers is the whole number which is a factor of all the given numbers. Example, we have to find the HCF of 16 and 24. Okay, so first method is, first we will write the factors of 16s. Okay, factors of 16, 1, 2, 4, 8, 16. And factors of 24, 1, 2, 3, 4, 6, 8, 12 and 24. Now find the common factors. Common factors are 1, 2, 4, 8. Okay, and HCF means highest common factor is what? 8. Right. Number 2 is prime factorization method. Okay, first we will find the prime factors of 16 then 24. See, now the common factors 2, 2, 2. Here too, we will multiply only the common factors. So the HCF is 8. Number 3 is a shorter method. 16, 24. 2 8s are 16, 2 12s are 24. 2 4s are 8, 2 6s are 12. 2 2s are 4, 2 3s are 6. Okay, now this is the HCF, that is 2 into 2 into 2 into 2 into 2. 2 into 2 is 4, 4 into 2 is 8. Okay. In this method, we start dividing the number by the least common factor and stop when there is no common factor. Often we follow this method as it is easy and fast. Example 2. In example 2 also we have to find the HCF of 24, 64 and 80. Okay, so method 1 is prime factorization method. Okay, and then we will find the common factors and then we'll multiply all the common factors, right? Method 2 is, here also we will find the prime factors, okay, but we will not further divide all these numbers because now there is no common factor which can divide all these three numbers. Okay, so the HCF is 2 into 2 into 2 is equals to 8. Long division method, prime factorization method is convenient to find the HCF of smaller numbers. However, when we have to find the HCF of bigger numbers, we follow the long division method. We proceed as follows. Number 1, first divide the larger number by the smaller number, obtain the remainder. Number 2, divide the divisor by the remainder. Repeat the process till we obtain a 0 as a remainder. The last divisor which gives a remainder as 0 is HCF. Okay, let's do the example 476 and we have to find the HCF of 476 and 1106. So we will divide a bigger number with the smaller one. Okay, so 476 2s are 952. Okay, 6 minus 2 is 4, 10 minus 5 is 5. Okay, and here 1. Now the divisor becomes the dividend. Okay, 154 3s are 462, 14. Now this will become remainder, will become divisor, and here divisor which is 154 will become the dividend. Okay, 14 ones are 14, 1, 14 ones are 14. Now the remainder is 0. So the HCF is 14. Okay. Similarly, you will find the HCF of three numbers also by division methods only. Okay. Let's do exercise 6.2. Find the HCF of 27 and 36. Okay. Let's find out the HCF of 27 and 36. 3 9s are 27, 3 3s are 9 and 3 1s are 3. Okay. Now 3 1s are 3, 3 2s are 6. 3 4s are 12. 2 into 2 4, 2 into 1. Okay, now let's find out the LCM. See, you have 3 here, here also 3. Okay, so 3 into 3 is what? 9. 9 is the HCF of 27 and 36, right? Next, least common multiples, that is LCM. We know that the least common multiple of two or more numbers is the least number that is a multiple of each of the given numbers. Example, find the LCM of 8 and 12. First, we will write the multiples of 8, then we will write multiples of 12, and then we will find out which are the common multiples. Here, 24, 48 and 72 and also 96, these are the common multiples. And among these common multiples, we have to find which one is the lowest. Obviously, out of these, 24 is the lowest. That means LCM of 8 and 12 is what? 24. Okay. To find LCM by prime factorization method. To find the LCM of two or more numbers, we express each one of them as the product of prime factors. Then the product of terms with the highest powers of all the factors gives their LCM. Let's do example 1. Find the LCM of 60, 72 and 96. Okay. So, first what will we do? We will find out the prime factors of 60. 2, 30 and 2 15s are 30, 3 5s are 15, 5 1s are 5. Okay. Then we have 72, 2 3s are 6 and 2 6s are 12. 2 ones are 2, 2 8s are 16, 2 9s are 18, and 3 ones are 3, 3 threes are 9, and 3 ones are 3. Okay, next is 96. We'll start dividing by 2. 2 4s are 8, 2 8s are 16, 2 2s are 4, 2 4s are 8, 2 1s are 2, 2 2s are 4, 2 6 are 12, then 2 3s are 6, and 3 1s are 3. Okay, now LCM is what? Product of terms consisting maximum number of 2, 3 and 5. So maximum number of terms containing of 2 is, see how many 2's are there? 5. Then maximum terms containing maximum number of 3 is 3 into 3. Okay, and then 5. So the product is 1440. That is LCM is 1440. Okay, to find the LCM by division method, we find the following steps. Number 1, we arrange the given numbers in a line in any order. Number 2, divide by a number which divides exactly at least 2 of the given numbers and carry forward the numbers which are not divisible. Number 3, repeat the above process till no 2 of the numbers are divisible by a same number other than 1. 4, LCM of the given numbers is the product of the divisor and the undivided numbers. Okay, now let's do example 2. Find the LCM of 27, 81 and 180. We have 27, 81 and 180. Okay, so first we'll divide by 3. 3 9s are 18, 3 9s are 27, 3 2s are 6, 3 7s are 21 and 60. Then again 3 3s are 9, 3 9s are 27 and 3 20s are 60. Now 3 1s are 3, 3 3s are 9 and 20 we will write as it is. Now let's find the LCM. LCM is what? 3 into 3 into 3. And now we will also multiply these two numbers. Okay, 3 into 20, right? 3 into 3, 9, 9 into 3, 27 and 27 into 3 is 81 into 20. Now 0, 2 1s are 2, 2 8s are 60. So 1620 is the LCM. Okay. Similarly, you will do this example also. Properties of LCM. The LCM of two prime numbers is their product. Okay. Whenever you are finding the LCM of any two prime numbers, the LCM will be their product. Okay. For example, if you are finding LCM of 5 and 7, both are prime numbers and the LCM will be the product of these two numbers, that is 35. Okay. Example, LCM of 7 and 5 is 7 into 5, that is 35. Okay. Number 2, LCM of two or more numbers cannot be less than either of them. Okay. Now, relationship between HCF and LCM of two numbers. Let us consider the following table. See, numbers 6 and 8, their HCF is 2, LCM is 24 and LCM into HCF is 48 and product of the given number is 48. Okay. Similarly, 12 and 16, these are the numbers, HCF is 4, LCM is 48 and LCM into HCF is 192. So, from this chart we conclude that product of two given numbers is equals to product of their HCF and LCM. And if you have to find the LCM of two given numbers, you will multiply first number and second number, then you will divide by the HCF. Okay. Note, this is applicable for only two numbers, not for more than two numbers. Okay. Okay. Find the LCM of 125 and 650. Okay. So, LCM is what? Product of two numbers, that is 125 and 650 upon HCF. But wait a minute, we do not have HCF, means first we need to find the HCF. Okay. So, let us find out the HCF by division method. We will divide 650 by 125. 125s are 6 to 5. 25, then 125. 25 5s are 125. Okay. So, what is the HCF? 25 is the HCF. Okay. Now, we will write 125 into 650 into what is the HCF? 25. Okay. 25 5s are what? 125. Now 0, 5 5s are 25, 2 carry, 5 6 are 30 plus 2 32. So this is the LCM. Okay. Now example 4. Find the smallest number of 5 digits which when divided by 12, 16, 20 and 24 leaves no remainder. Okay. Smallest number means least number. Whenever this particular term is used, that is the smallest number or least number, you will always found LCM. We will always found LCM. Okay. So we have to find out the LCM of these numbers. Okay. So 240. We'll get, so 240 is the number which when divided by 12, 16, 20 and 24 leaves no remainder. Okay. Therefore, 240 is the smallest number that can be divided by 12, 16, 20 and 24 with no remainder. Now, we have to find the smallest multiple of 240 which is a 5-digit number. The smallest 5-digit number is what? 10,000. So, we will divide 10,000 by 240. Now, when we will divide 10,000 by 240, we get a remainder 160. It means that the smallest 5-digit number divisible by 240 will be 42nd multiple of 240. So, smallest 5-digit number exactly divisible by 240 is 1080. Means you will multiply 240 by 42. Why 42? Because quotient we got 41, but there is remainder also, so we will multiply 240 by the next digit, that is after 41, which is 42. Okay. Example 5. Find the greatest number of 6 digits which when divided by 18, 27, 36 and 45 leaves no remainder. Greatest number or highest number, if these two terms are used, we always find HCF. Okay. But first, what will you do? We will find the LCM of these 4 numbers, that is 18, 27, 36 and 45. So, the LCM is 540. Now, the greatest 6-digit number is what? 6 times 9. This is the greatest 6-digit number. We have to find greatest 6-digit numbers. So, we will divide it by first 540. Okay. And after dividing, we get a remainder 459. Right. So, hence the greatest 6-digit number exactly divisible will be obtained by subtracting 459 from this number, which is greatest 6-digit number. Okay. You will subtract what? You will subtract the remainder. 9 minus 9 is 0, 9 minus 1 is 8, 9 minus 4 is 5. Okay. So, this is the largest 6-digit number. When divided by 18, 27, 36 and 45 leaves no remainder. Okay. Exercise 6.3. Write the prime factors of each number and find the LCM. 12. 2 6 are 12, 2 3s are 6, 3 1s are 3 and 16. 2 8s are 16, 2 4s are 8, 2 2s are 4 and 2 1s are 2. Okay. Now, the LCM is what? 2 into 2 into 2 into 2 into 3. 2 2s are 4, 4 2s are 8, 8 2s are 16 and 16 3s are 48. Okay, students. Now, you will do practice of the remaining questions.